This is Barely Berry Jr., and we're going to go ahead and continue with some classical dynamics, getting our work ready for the fall. And I already started on here a bit. I found that the example was a bit cryptic, but I actually filtered out with numbers. So why don't we go through the textbook and see if we can put the uh, sort of symbolic lettering that they had. So this is basically figure 1.2. Sort of filled out. We'll see if we can finish chapter 1 by the time class starts next week. It's long enough, 43 pages, so 40 more pages, so we could do that. So looking at the figure, so I did this to scale pretty well. So y is x2. So this would be y equals 13 and x equals 6. And we have, this is x2 prime, or y prime equals that, and x prime equals that. So these are the two coordinate systems representing that point. So the point is the same, but the coordinate system has been rotated. So x1, x prime is a sum of the projection of x1 onto the x prime axis plus the sum of the projection. Hey, what's going on, real kindness? Getting one in. I've been so busy doing other things that I haven't done a video on here in a while. So this is a class I'll be taking in the fall. I actually started it in the spring, but my but my schedule didn't quite allow it, so I dropped it. Even though I don't know, I got a few weeks in. So I'm taking it again. Same professor. Looks like the setup is a bit it's the same, except I'll be able to put more time into it this time. And my goal is to get an A. If I get an A on everything, then I can graduate with a low A. So we'll see. But this is the work that I started on in the last video. The this is actually the same book that I showed on MC Tunes channel last night, but I'm looking at the actual book. Let me share that screen. Where do I have it at? Right. So this is the book here. It's a bit humongous. So this is the diagram that we're looking at right there. So the way they have it there, at least to me, it seemed kind of weird. But like I said in the stream the other day, the books always seem weird how they do things. I don't know. So I ended up just doing it with numbers. And when I actually filled the thing out with numbers, I was able to identify that the process is correct. That if you take the projection of x onto x prime, which is this, and I got this from my linear algebra class, and the x prime will end up being basically those two things added together. So basically, I'm actually backtracking on it because it's been so long since I did it. It's been about a week or two. Uh, but looking at the diagram, and I use my little ruler that's up inside this program to measure everything. Seems pretty okay. But I think I always had sort of a problem with transforming coordinates, but I'm gonna have to get used to it. Uh, I don't have a PDF link. There was passing a PDF around in class that I put in my Kindle, but you probably have it around here somewhere, I guess. But the thing about the Kindle book, I mean, the PDF book, is not complete. It like misses pages and stuff. I just pulled it up fast in the stream because I wasn't sure if I can log into this to the actual book fast enough. But I don't actually use it for class. When I went through it, it misses a lot of pages. I don't know who put that thing together, but it's not really that good. Um, or I actually already had this book, the actual book, before they got that, but somebody was just passing it along, and I was like, well, might as well have it since they're passing it around. But it's actually not very good. Like I wouldn't trust it for classes. I don't know who put it together or how, but they didn't do a good job. But so I mean I think I did this enough. I don't mind going to the next section. Um, I may have to just revisit this section again. Okay, now that we're getting into some linear algebra, so we have to do a transformation section. It's like they're doing linear algebra, but uh, okay, let's slow down and see what they're talking about. Interesting. I think they're making a matrix out of those numbers. Okay, now this is something I don't think I've seen before. So I got y prime from adding these two, and x prime was the same up here, adding those together, and x1 would have been this point, the projection of x onto x1. And the thing that's weird about this is, so this is my x. I actually redrew this here. So if you look at this x right here, this x, this x is this x. I just rotated it around. And this x prime right here is this x prime. So this is how I got the projection, which is the projection of x onto x prime. So I projected this 6 down to the x prime axis, which would be equivalent to this projection here. So the projection that I did to get that value is that. That's the same thing as this right here. So I shall recreate this. So projection of x on the x prime, or x on the x prime, x is this, which is 6, 0. And this definition is from linear algebra. So it's basically x1, which is going to be this x prime. Mm, okay. So instead of using the official one, this is the sort of shortcut that we use in my EM class for dot product. So magnitude of x, which would be the magnitude of 6, 0, but that's of course 6. The magnitude of x prime would be utilizing the formula. So I guess this is just something I have to remember. Whenever I want to get the x prime thing, there's always going to be at least the x, the sort of x value of it, of x prime, will be the original x cosine theta plus the original y sine theta. And this will give you your x prime. And the y will be the, or y prime would be the negative x cosine 90 minus theta plus y cosine theta. And this reminds me of something from my first quantum class. I took that pass fail because it was a rough class. Um, oh, and crap! The thing wasn't. I was blocking the book, but yeah, I'm gonna have to work through this transformation again and refresh myself. It looks like what they're gonna do is they're gonna end up taking one of these transformations and make it a one term inside the transformation matrix, which ironically I don't remember doing in the actual class, but it wasn't in the full class, like I was saying earlier. But um, this is like pretty much the first thing they mentioned in the entire thing. So this is the next section. So what I may do for next time, uh, I'll go ahead and rework the details of this because apparently I did something different than what they did in the book. I'll refresh myself on what I did to get my own version of this program because I noticed this outcome. Because I noticed that they have a slightly different formula than the one I used here. But I remember this book being okay, but the first time I didn't go through the first uh chapter. So the class starts on chapter 2. So I figured this time I will go ahead and start on chapter 1 myself. But this is where chapter 2 starts at, Newtonian mechanics with a single particle, which again flies in the face of all the first nonsense. Um, so we start with that. This is pretty much ended up having to do some of the things that I derived in the video yesterday on MC Tunes channel. And so maybe I'd even be able to get to some of this again on before Monday comes. So if I remember right, my first class, I remember this one is a Tuesday or Thursday class. This is a Tuesday class. So actually I have till Monday as well. So I'll see about Monday night, or at least finish chapter 1. So what I'll do, why don't I schedule something for tomorrow and I will recap the process I did to get that and perhaps start on the next section. So, and actually I have to do have an exam Saturday as well. So maybe that's not the best time. Maybe I'll set something for Saturday instead. So let's say I'll be back Saturday evening. and I'll do some more details on the transformation and revamp that and find out and remind myself whatever method I use to not use the book method, because I would like to make sure I have that process down rather than memorizing the formula. So I'll say Saturday at, let's say, 7 p.m. Central Time. So look for me then, and I'll be back. And what I'll do, we'll start from figure 1.2, and I'll make sure to backtrack the actual shortcut. Maybe it's not a shortcut, but I definitely did it differently than the book has it. So I'll go through and remember what I did to get this, refresh my memory, and then we'll continue from that part and see this new thing that they're talking about, where actually we'll end up taking these values for x prime and y prime and putting them into their own matrix. So it seems like that'll be interesting. I remember around the time when I dropped the class, they started doing like Lagrange things. So I figured something like this to help with that. Always good seeing you, Real Kindness. Look for me on Saturday as far as this topic, and I may actually do some kind of first video before then. But I'll definitely be here. Most of my videos will probably be here throughout the semester, but I do plan on still keeping up with the other channel. But during the semester, I'll be doing quantum physics. I'll be doing this. Well, pretty much all my classes. So this semester, I'll be taking quantum. I'll be taking classical electrodynamics, which is like the next level of EM. I'll be taking astronomy research. So probably won't be doing videos on that because that'll be more like lab work and stuff. And so that'll probably be the things: classical electrodynamics, quantum, and classical dynamics. And everything else is mostly lab stuff. So cool, man. I'll see you next time.